Hello students, so today we will start with the new topic, that is equilibrium constant, and we are going to derive the formula to calculate the equilibrium constant from the Nernst equation. So for deriving this formula, we will take the example of the Daniell cell, and this cell we have discussed many times earlier. It consists of two electrodes, one of which is zinc metal and other is made up of copper metal. So the zinc metal electrode is anode and it gets rapidly oxidized, whereas the copper metal is cathode, and at this electrode a reduction reaction takes place. And in the previous topic we have calculated the standard electrode potential of the Daniell cell, and it was calculated to be 1.1 volt using the simple hydrogen electrode, or the standard hydrogen electrode, which is used as a reference electrode. So now, according to the law of chemical equilibrium, the equilibrium constant, that is Kc, it is equal to the product of the concentration of the product. So what is the concentration of the product? This is the concentration of the product, and left hand side is the concentration of the reactant. This thing should be clear to you. This is the concentration of the reactant, and right hand side this is the concentration of the product in the overall reaction of the Daniell cell. This is the overall reaction. So reactant and product is clear. So according to the law of chemical equilibrium, the equilibrium constant Kc is equal to the product of the concentration of the product. Concentration terms we write within the parenthesis, or we write it in the square bracket. So the next thing, divided by the product of the concentration of the reactant. In the reactant side you can see here there is copper 2 plus ion and the other one is zinc solid. So these are the things. Now the next thing is the concentration of the copper solid. So where is copper solid metal? It is in the product side, whereas the zinc solid metal, these two concentrations will be considered as unity, because according to the condition, when a gas is evolved like chlorine, nitrogen, oxygen or any other gas, or in case of solids, when a metal is produced, its concentration is not in the ionic form so that we can measure it. So when it is in the solid form or the reduced form, we take it as unity, means 1. So according to the Nernst equation, I have written with the red text, you can see it. Nernst equation, E of the cell, EMF of the cell, or we can also say cell potential at any concentration, is equal to the standard reduction potential of the cell. This is standard reduction potential. we are taking the example of the Daniell cell. So here its value is 1.1. So 1.1 value we got by the difference of the electrode potential of the cathode माइनस स्टैंडर्ड इलेक्ट्रोड पोटेंशियल ऑफ द एनोड। तो दोनों इलेक्ट्रोड्स के जब स्टैंडर्ड रिडक्शन पोटेंशियल के डिफरेंस को हम मेजर करते हैं, दैट गिव्स अस द वैल्यू ऑफ स्टैंडर्ड रिडक्शन पोटेंशियल ऑफ द सेल माइनस 2.303 R into T divided by N. N is the number of electron transferred into F. F is the Faraday's constant having value 96500, 96,500 coulombs, and R the value of R is 8.314. Temperature we write for the standard condition, it is 298 Kelvin. And next is the concentration terms, that is zinc 2 positive ion and copper 2 positive ion. So this thing we have discussed in the Nernst equation calculation. And now when the reaction is at equilibrium stage, means the rate of the forward reaction is equal to the rate of the backward reaction, then E of the cell means EMF of the cell becomes equal to 0. No current will be produced, no electricity will be produced, no transfer of electrons will be take place. So at this stage this thing becomes equal to 0. So what is left behind? E naught of the cell, it remains constant, it has no any relationship with the equilibrium constant, its value remains constant if it is 1.1 volt. So whatever the concentration of the reactant or product, it will remains at 1.1 volt. So when we further calculate the values of these four parameters, that is 2.303 multiplied by 8.314 multiplied by 298 Kelvin and divided by Faraday constant, it becomes 0.0591. So you can also round off this value as 0.06. For calculating the numerical in a fast way, we can round off this value as 0.06. The answer comes very same and very close to the accurate one. So we can also consider this value. So divided by N, number of electrons transferred, here you can write the value of N as 2 log Kc. When the concentration of the reactant and product becomes equal, then this value we can write as Kc. Next thing is we have to derive the formula in which we can calculate log Kc or ultimately the Kc. So rearranging this formula, we get log Kc is equal to E naught of the cell into N number of electron transferred divided by 0.0591. So when we calculate this, put the values and calculate the above expression, we got the result as 37.29. What this thing is? The value of log Kc. Log Kc is equal to 37.29. But in fact we have to find out the value of Kc. We have to find the value of Kc. So Kc becomes equal to antilog of 37.29. So 37 is called the characteristic. So it will becomes the power of 10, and we will see the value of 0.29 from the anti-logarithmic table, because the anti-log value is only taken for the decimal part and it should be positive one. It should not be a negative one value. So if it is negative in special case, then we have to convert it into a positive value by adding or subtracting 1 in both the sides, whether it is the characteristic part or whether it is mantissa part. So let us see how to calculate the value of 0.29 from the anti-logarithmic table. So actually we need 4 digit decimal 4 values to get the accurate one, but if we do not have the 4 values, then we can calculate as 0.29, then we can add zeros by our own self. So this is decimal 0.29. So this is the anti-logarithmic table, as you can see here, in which the two numbers are utilized to locate the particular number in the series. Suppose it is 29, so I am locating it here. .29, it is the last number of the series. Here you will come to know that how to calculate the value of antilog value of a particular digit. Suppose we have given only 0.29. So in order to get the correct value, we should have 4 digit in the mantissa part, but if it is 2 number, then we can add 2 zeros. So firstly we have to locate this 0.29 in the given series. So this value is 0.29 as I have circled here. So now 0.29 का हमें मीन वैल्यू देखनी है, जो कि क्या है 0. ये 0 पे हम देखेंगे, जैसे मैंने यहाँ पे रेड मार्क्स में कर दिया हुआ है 0 1 2 3 4 5 6 7 8 9. तो ये जो फर्स्ट 0 से 9 तक वैल्यू, इनको हम बोलते हैं मीन वैल्यूज़. और अगर फोर्थ डिजिट भी हमारे पास है तो उसका भी जो फ्रैक्शनल वैल्यू होगी वो उसमें ऐड हो जाएगी, सम कर देते हैं उसको भी. तो 29 डेसिमल 29 का जो 0 पे वैल्यू है वो हमें मिल रहा है 1950. ये वैल्यू हम नोट कर लेंगे. और इसकी कोई फ्रैक्शनल वैल्यू है ही नहीं, क्योंकि 0.29 का 0 पे कोई आगे वैल्यू होती नहीं है, जस्ट 1 से शुरू होती है. फ्रैक्शनल वैल्यू जो 1 से शुरू होती है. सो अब 1950 हम वैल्यू ले करके चलते हैं अपने मेन आंसर की तरफ. सो यहाँ पे 1 सो यहाँ पे हम लिख देंगे 1950. लेकिन इसमें आप देख रहे हो कि डेसिमल नहीं लगा है. तो डेसिमल जैसे कि हम साइंटिफिक नंबर लिखते हैं उस तरीके से एक डिजिट के बाद हम यहाँ पे डेसिमल लगा देंगे, राइट. तो हमारा जो आंसर है वो आ जाएगा 1.950 इंटू 10⁻37. सो इस तरीके से बच्चों हम जो है इक्विलिब्रियम कांस्टेंट Kc की वैल्यू फाइंड आउट कर सकते हैं, राइट. सो अब हम कल जो है अगला टॉपिक